Hey guys, this is the 2.3 notes. It deals with parallel lines and triangle angle sums. Um, so the first three theorems will help us solve certain problems in this section. So the first theorem says through a point not on a line, there is one and only one line parallel to the given line. Okay. So this is normally called the parallel postulate. Okay. And essentially what it's saying is there's one unique line, say A. So we have that line A right here. So there's one unique line, which we call A, that passes through point P. And it is parallel to line B. Okay. So there's only one line that goes through that point P that can be parallel to B, right? And in this case, it's line A. The next one is the triangle angle sum theorem. What this tells us is just the sum of the measures of all the angles of a triangle is 180 degrees. So these three angles added together equal 180 degrees. So we can say measure of angle A plus measure of angle B plus measure of angle C, right, is equal to 180 degrees. So they have to equal 180. So if you're given like A and B, right, C has to be a measure that adds to A and B to equal 180 degrees, and vice versa with other angles. Okay, so all three angles in that triangle need to add to 180 degrees, essentially. That is what the triangle angle sum theorem tells us. The last one is the triangle exterior angle theorem. Okay, so you can see there's an angle 1 on the outside. Okay, so this says if the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. Well, remote interior angles are these here. So remote interior angles. Okay, so these two, 3 and 2, right? See how they are not touching angle 1? Therefore, they're remote. So remote, interior remote angles do not touch the exterior angle. Okay, so the two angles inside the triangle not touching one. Okay, and this says the measure of each exterior angle is equal to the sum of the remote angles. So we can say measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay, so the two remote angles, right? Angles add up to equal the one exterior angle. Right, and that's because if if we had 3 and 2, right, this angle inside right here that we have not marked, essentially what that's going to do is that angle plus 2 and 3 give you 180, right? And that this angle right here and 1 are linear pairs, so they add to 180. So, right, if you subtract that inside angle from angle 2 and angle 3, right, you get that angle 1. Right, but essentially, just remember that exterior angle is equal to their two remote angles added together. All right, now because we know these three theorems from up top, we can determine the values of x and y given certain triangles. Okay, so let's look at A. Okay, so we can either find x or y first. I think finding x first is easiest because we have two angle measures and we know all three of them equal to 180. So we can set 35 degrees plus 96 degrees plus measure of angle x is equal to 180 degrees. Right? Then just subtract, so you can add these together. You get 131 degrees plus measure of angle x equals 180. Right, I'll make a section. And then you just subtract 131 from both sides. So the measure of angle x is 49 degrees. Because 180 minus 131 is 49 degrees. All right, so that's using the triangle angle sum theorem. Now to find y, right, if we think about it, right, if we pull out this triangle here, we have 77, and we have y, and we have 96, right? These two angles right here are our remote angles, y and 77, and they equal the exterior angle. So we can do y plus 77 degrees, right? Measure of angle y plus 77 degrees equals 96 degrees, right? And that's our triangle exterior angle theorem. Right? The first one we use triangle sum theorem. This one we're using triangle exterior angle theorem because 96 is the exterior angle, y and 77 are the remote angles. So we just subtract 77 from both sides and we get y equals 19 degrees. Okay, so that's using our second and third theorems. All right, let's move on to B. All right, so we can find x by adding these three angles right together and saying them equal to 180 degrees because of the triangle angle sum theorem. Right, it tells us that measure of angle x plus 57 degrees plus 59 degrees equals 180 degrees. Because in this triangle right here, right, all three angles add together equals 180. Right, so we subtract 57 and 59 to the other side, and measure of angle x equals 64 degrees. Right, and if you wanted to check yourself, add 64 plus 57 plus 59, it needs to equal 180, which it does. All right. Now, we can exchange x degrees to 64 degrees. Now, since we know x is vertical to, we say, let me call this z. Right? If they are vertical angles, they are equal. Okay, so this z degrees needs to be 64 degrees as well, because z and x are congruent because they are vertical angles. Now we can use the triangle angle sum theorem again to solve for y. So we have 42 degrees plus 64 degrees because we know that angle z that we marked as z is 64 degrees because it's vertical to angle x, plus measure of y, angle y, is equal to 180 degrees. Subtract 42 and 64 from 180. We get measure of angle y is equal to 74 degrees. Right? 74 plus 64 plus 42 gives you 180. So that's correct. Okay. All right. C, right? Again, we can solve for x. Right? So 54 plus 23 degrees plus measure of angle x is equal to 180. Subtract 54 and 23, right? Or subtract 77 essentially from 180, and we get 103 degrees for x. All right. Now, we can go about this a couple different ways, right? What I'm going to do is I'm going to get rid of this line right here, okay? So I'm going to redraw this without that interior line where x is. So we have y degrees, we have 54 degrees. Now this angle here is adding 23 plus 36, right? 23 degrees plus 36 degrees, right? Gives us that other angle, which is 59 degrees. Okay, I got that 59 from right here because this total angle is 59 degrees because 23 plus 36. Now using the triangle exterior angle theorem, we know that the two remote angles, right? These are remote angles, and this is our exterior, right? Equal our exterior angle. So 59 degrees plus 54 degrees equals y degrees, measure of angle y. So measure of angle y is equal to 113 degrees. Okay. So I'm just going to give the answers for these. So if you want to try this, go through it, pause the video now, and you can try these. Okay, so hopefully you've tried them. So for this one, right, if we have an exterior angle, our two remote angles equal it. So 75 degrees plus 45 degrees equals angle 1. So measure of angle 1 is 120. Oop. This one we have remote angles here. This is our exterior. So add our remote angles, 51 degrees plus measure of angle 2 equals 109. And then so measure of angle 2 equals, 58 degrees, right? All right, so we have a proof of the triangle angle sum theorem to prove that the angles are equal to 100 degrees, all three of them. What I'm going to do is I'm not going to make you go through this. I'm not really going to go through this. I'll show you the solution just so you have it. But it's really not too important to this section. It just proves why we can say that the three measures of the angles inside our triangle equals 180 degrees. All right, now for this one, right, we want to find the measures of angle 1, angle 2, and angle 3. Now, let's see what we can solve for. So the first thing we can solve for is angle 2. Right. We know that these two are going to be parallel. Okay. So, because it says each shelf is parallel to its base. Okay. So what we can do for angle 2 is pull out, right, that parallel line here, and then that baseline here. And then we have a transversal at that 55 degrees. Essentially, like that'd be our transversal. Right, here's the 55 degrees from the picture, from right here. And then angle 2, right, it would be angle 2 is right here. Okay. Now, we can say angle 2 is equal to 55 degrees, right? Why is that? Because they are alternate interior angles. All right, and that brings us back to the first section, right? They're alternate interior angles, which we know are congruent. Therefore, angle 2 is equal to 55 degrees. All right, next, let's solve for angle 1. For angle 1, I'm going to pull out the two parallel lines again. Right, and then we have line going here to here. Let's get 75 degrees. Right, and then we also have a line crossing here. So we have angle 1 and 55 degrees. If we think about it, right, 75 degrees and this included angle 1 and 55 degrees together should be equal to that 75 because they're corresponding. Right, so 75 degrees and angle 1 plus 55 degrees are corresponding. So we set them equal to each other. So angle 1 plus 55 degrees equals 75 because, again, they're corresponding. So we set them equal to each other. So, right, angle 1 is equal to 20 degrees. Right, so we got 1, 2, and now we need to find 3. Okay. All right, to find 3, what we're going to do is we're going to take out this whole triangle here. Right, so if we take out this triangle, right, we have 45, we have 45, and then, right, we have technically a 55, a 1, and a 3, right? So I just pulled out that triangle. Now, we should know that this whole angle equals 90 degrees, right? Because 45 plus 45 is 90, and then the 3 angles of a triangle equal 180. So we can set 55 plus angle 1 plus angle 3 equal to 90 degrees. If you didn't surmise that, you could also do 55 plus angle 1 plus angle 3 plus 45 plus 45 equals 180. Right? But I just kind of broke it down a little smaller. Right? We know angle 1 is 20 degrees, so we're going to substitute in 20 for angle 1. And that will help us solve for angle 3. So we get 75 plus angle 3 equals 90. So angle 3 is equal to 15 degrees. And now we have 1, 2, and 3.